So if you're listening to this right now, there is a very high probability that you are drinking a cup of coffee. Or, at the very least, you've probably had one in the last 24 hours.
Oh, absolutely. It's the universal morning ritual.
Right. And for the vast majority of us, that liquid in your cup, that is the absolute totality of our relationship with the coffee plant. I mean, we treat it like a delivery mechanism for caffeine.
Just a way to brute force our brains into waking up for an 8 a.m. meeting, right?
Exactly. It's a highly engineered extraction of a single roasted seed. We take that seed, we grind it up, we run some hot water through it, and then we just discard the rest.
We really do.
But if you actually stop, and I mean really stop, and look at the botanical reality of what you're consuming, you're engaging with this microscopic fraction of a massive complex organism.
You're using one tiny seed from a cherry that grows on a dense woody shrub.
Which begs a rather massive question about our consumption habits. What is happening to the rest of the plant?
It's a remarkable cognitive blind spot, honestly. I mean, in the modern industrialized model, we're obsessively focused on this one tiny endosperm,
right?
And we completely ignore the entire biological architecture that built it. The leaves, the wood, the bark, the sap, the fruit skin, all of these represent a staggering amount of biomass.
And chemical complexity, too.
Exactly. Yet, in the global coffee trade, they're just treated as an afterthought. Or worse, like an industrial nuisance that we have to pay to dispose of.
Well, that structural blindness is exactly what we are dismantling in today's deep dive. We are stepping entirely outside the parameters of your conventional coffee shop.
I love that. We're leaving the cafe behind.
We are. Our focus today is on the ethnobotany of the coffee plant within Nusantara, which is the vast, incredibly diverse Indonesian archipelago. It's such a fascinating region for this. It really is. We are going to examine how indigenous knowledge systems in this region approach the coffee plant. And spoiler alert, it is not as a single product factory.
No, not at all.
Yeah.
It's an integrated system of survival, medicine, and cultural identity.
So we have some incredible source material on the desk today. We're working from a central documentary script titled Ethnobotany Nusantara. Basically the cultural footprints and local wisdom of the coffee tree.
And to ground that narrative, in rigorous science, we are cross-referencing it with 3 recent academic papers.
Yeah, we've got Jumari et al. From 2025, Pribadi et al. From 2024, and Sukenti et al. From 2019.
Right, and together, these sources provide this deeply granular look at how different communities across the archipelago interact with every single element of the plant ecosystem.
Okay, let's unpack this, because the term ethnobotany gets thrown around a lot in academic circles.
It does.
And I think it often conjures up images of, researchers in pith helmets cataloging Latin plant names in a jungle. But how are we defining it today?
Yeah, the clinical sound of the word ethnobotany really does it a disservice. It is fundamentally the study of the relationship between humans and plants.
So it's not just taxonomy.
Far from it. Traditional botany might focus entirely on, say, the cellular structure of a leaf or the genetic lineage of a root system. Right. But ethnobotany looks at that exact same leaf and asks, how does the chemical structure of this plant dictate the societal structure of the humans living right next to it?
Oh, wow. That's a great way to put it.
Right. Like, how does it influence their medicine, their economy, their caloric intake, their theology? When you look through an ethnobotanical framework, you're actually observing human adaptation. You're looking at survival mechanics.
What's fascinating here is that when you apply that ethnobotanical framework to the coffee plant in these specific Indonesian regions, the concept of waste just completely vanishes.
That's incredible.
I mean, the modern agricultural world is currently drowning in biological waste. But these communities have engineered systems of holistic resource management that are astonishing. They treat the coffee plant as a tree of life.
That phrase, tree of life, it perfectly encapsulates the paradigm shift.
Yeah.
It moves the plant out of this rigid category of cash crop.
Right. It's not just a commodity.
Exactly. It elevates it into a foundational community pillar. It's no longer just something you harvest to sell. It's a partner you rely on to survive.
Let's look at exactly how that partnership functions on the ground. Because the Jumari research from 2025 gives us this highly detailed case study in central Java.
Specifically, Indrokilo hamlet.
Yes, situated in Lerp village. The researchers actually embedded themselves there to observe the farming practices, and the utilization of the coffee plant is just exhaustive.
It really leaves nothing behind.
Let's start with the leaves. In a standard Colombian or Ethiopian commercial plantation, leaves are just the solar panels required to grow the bean. Nobody harvests them.
Right. They just get left on the bush or tossed during pruning.
But in Indrokilo, the coffee leaves are intentionally harvested. They're boiled and consumed as a primary medicinal tea to relieve physical fatigue and boost stamina.
And the pharmacology behind this is fascinating. It makes perfect sense when you understand plant chemistry.
Break that down for us, because I think people just assume it's like drinking a weak cup of regular coffee.
Not at all.
Yeah.
So we isolate caffeine from the bean because it's highly concentrated there. But the coffee plant produces a vast array of secondary metabolites throughout its entire structure.
As a defense mechanism, right?
Exactly. Defense against herbivores, pathogens, sunburn, you name it. So the leaves are incredibly rich in phytochemicals.
Including caffeine.
Lower concentrations of caffeine, yes.
Yeah.
But also really high levels of chlorogenic acids, mangiferin, and various specific alkaloids.
So by boiling the leaves, they are essentially extracting a totally different chemical profile than what you get from roasting the seed.
That is exactly the case. Boiling acts as a solvent extraction. Hot water breaks down the cellular walls of the leaf, releasing those water-soluble antioxidants into the liquid.
And what do those compounds actually do in the human body?
Well, chlorogenic acid, for instance, is known for its anti-inflammatory properties. It also modulates glucose metabolism. And mangiferin is a really potent antioxidant.
So when the local farmers drink this leaf decoction for stamina, they aren't just getting a caffeine buzz.
No, they are ingesting a complex matrix of compounds that actively reduce cellular stress and inflammation caused by hard agricultural labor.
They've engineered a localized pharmacy right in their backyard.
Exactly. It fundamentally redefines the utility of the plant.
Okay, so if the leaves are your pharmacy, what happens to the fruit itself? Because this is where the global coffee industry creates an almost incomprehensible amount of waste.
Oh, it's a massive environmental issue.
Right. To get to the coffee bean, you have to strip away the outer skin and that fleshy, sticky pulp. And in industrial setups, millions of tons of this fruit biomass are just discarded.
It just piles up.
Yeah.
And it ferments rapidly, which can severely pollute local water tables.
Because it sucks all the oxygen out of the water, right?
Yes, it has a very high biochemical oxygen demand. It basically chokes the local aquatic ecosystems.
But the Jamari paper notes that in Indrokilo, this fruit skin is treated as a highly valuable secondary harvest. They don't let it rot.
This is a critical point regarding ecological management. They bypass the toxicity entirely. Instead of letting it ferment into a hazard, the community meticulously collects the skins and sun-dries them.
Which stops the rotting process.
Exactly. It halts decomposition and preserves the fruit sugars and organic compounds. And the resulting dried product is called Cascara.
And the sources are very specific about the sensory experience of Cascara. They describe it as being brewed into a refreshing herbal drink with a distinctively sweet aroma.
Which is very different from regular coffee.
Right, it's a complete departure from that dark, bitter, roasted flavor profile. It's fruity, it's floral.
Because you are tasting the actual fruit sugars and organic acids from the cherry skin, it's entirely separate from the deep Maillard reactions and caramelization that happen when you roast a seed at 400 degrees.
It's essentially a fruit tea derived from the coffee plant.
Yeah. Providing hydration, a mild stimulant effect, and utilizing a massive percentage of physical mass that would otherwise be toxic waste.
I like to think of it as a nose-to-tail approach. You know how chefs talk about utilizing the whole animal? This is nose-to-tail agriculture.
Oh, I love that analogy. It's absolutely nose to tail.
And the ethnobotanical record shows that this philosophy extends into the structural architecture of the tree, too. Like, a coffee plant needs constant pruning, right?
Oh, yeah. Otherwise, it becomes an overgrown, tangled mess. Your yields drop significantly.
So in Indrokilo, the stems and branches from pruning don't go to a waste pile. They are systematically harvested and used as primary firewood for the village.
Which is a crucial aspect of the local carbon cycle. By using the dense, woody biomass of the coffee stems for domestic fuel, they reduce the need to deforest other surrounding areas for firewood.
It creates an internal energy economy right there on the farm.
Exactly. And they don't even just burn everything. The sources highlight that the bark of the coffee tree is actively stripped, chopped, and integrated into organic compost fertilizer.
Wait, why the bark specifically?
Well, the bark is heavily lignified tissue. It's tough, complex, structural carbon. When you chop it up and put it in a compost pile, it becomes a slow-release carbon source for the soil microbiome.
So the fungi and bacteria slowly break it down?
Yes, they break down the lignin and cellulose, transforming it into rich humus that feeds the root systems of the next generation of coffee plants.
It's a perfectly closed-loop system. The plant literally becomes the fertile ground for its own future growth.
It's brilliant resource management.
Here's where it gets really interesting, though. The Jumari paper mentions the sap of the tree. It notes that the sap is extracted and processed into a natural pesticide to repel small insects.
Yes, the biological defense mechanism.
When I read this, I was genuinely confused. How do you even extract sap from a coffee plant, and why does it work as a bug spray?
To understand the how, we have to look at the plant's vascular system. A tree has phloem, which transports sugars, and xylem, which transports water and minerals.
Right.
When a community taps into the plant, usually through careful scoring or just collecting what bleeds during pruning, they are accessing that internal circulatory system.
Okay, but why does it repel insects?
Over millions of years of evolutionary arms races, plants have developed highly sophisticated chemical defenses. They can't run away from predators, so they engage in chemical warfare.
Makes sense.
The sap of the coffee tree contains highly concentrated bitter alkaloids, terpenoids, and various resins,
Which are entirely toxic to bugs.
or at least highly unpleasant to the nervous systems of predatory insects. They act as antefeedants, meaning they disrupt the insect's ability to eat, or they actively interfere with its neurology.
And the farmers in Central Java just observed this. They realized the coffee plant already knows how to protect itself.
Precisely. By extracting that sap and applying it to other, more vulnerable crops, they are essentially harvesting the coffee plant's immune system.
And applying it broadly. That is incredible. You completely avoid the soil damage caused by synthetic broad-spectrum pesticides.
Which usually kill the beneficial microbes and the pollinators right along with the pests.
Exactly. This is an incredibly targeted biological deterrent. So we've got leaves for pharmacology, fruit skin for a secondary drink, wood for thermal energy, bark for soil regeneration, and sap for agricultural defense.
It covers almost every baseline necessity for physical survival.
It really does. But ethnobotany doesn't stop at raw utilitarianism. The researchers note a deeply cultural climax to this zero-waste philosophy, and it involves the flowers of the tree.
Yes, the coffee plant produces these beautiful clusters of highly fragrant, delicate white flowers before the fruit sets.
And in Indrokilo, they don't just let them wither and fall off. They carefully gather a portion of these flowers to use as aesthetic and aromatic decorations for sacred harvest Thanksgiving rituals.
The local Javanese refer to these rituals as bangkakan.
Which just shows that the plant is not just keeping them alive on a caloric level. It has been woven into the psychological fabric of the community.
If we connect this to the bigger picture, the inclusion of the flowers in the bangkakan ritual is profoundly significant. Harvest festivals are universal across agrarian societies, right?
Yeah, they're mechanisms for building social cohesion, expressing gratitude for survival.
Exactly. By placing the coffee flower at the visual and olfactory center of that ritual, they are elevating the plant from a tool of survival to an object of reverence.
The fragrance anchors the cultural memory of the harvest.
It ensures that the community never views the plant as a mere commodity. It's a living entity that requires respect and ritualized gratitude.
It's a completely holistic relationship. The plant touches every single layer of human experience in that hamlet.
It really does.
But, if Central Java gives us this incredibly literal physical utilization of the actual coffee plant, the next set of research takes us in a fascinating, almost philosophical direction.
Yes, regarding how we define our relationship with beverages entirely.
Right. We're looking at the research by Sikenti et al. From 2019, which shifts our focus eastward to the island of Lombok, specifically analyzing the ethnobotanical traditions of the Sasak tribe.
And this is where the terminology gets really interesting.
I actually found myself stumbling over the terminology when reading this paper. It heavily discusses various coffee substitutes used by the Sasak people.
Right.
And if you look at this purely through a Western botanical lens, a substitute implies you are trying to recreate the exact flavor profile of a roasted Arabica bean, like a fake version of the real thing.
But that's not what's happening here.
Not at all. As the researchers detail these drinks, it becomes clear the Sasak tribe isn't trying to fake a cappuccino. The word coffee in this context doesn't seem to be tied to a strict botanical classification at all.
It requires a major shift in how we interpret language within ethnobotany. In the context of the Sasak traditions, coffee is not a noun describing a specific seed.
So what is it?
It operates almost as a verb or a description of a specific social and physiological ritual. It denotes the act of sitting down, usually in the morning or during a gathering, and consuming a dark, hot, deeply functional, brewed liquid.
It's about the social utility, not the taxonomy.
Exactly. It's about the bodily intervention.
Which makes perfect sense of the first substitute the Security paper highlights, Kopi Kedele, or soybean coffee.
It sounds counterintuitive at first.
Totally. Initially, the idea of turning a soybean into coffee sounds like a severe mismatch. A soybean is a legume. It doesn't have the inherent complex acids or the caffeine that a coffee bean has.
Right.
So how do they bridge that gap to create a drink that fulfills the coffee ritual?
The bridge is the mastery of the roasting process, specifically the manipulation of the Maillard reaction.
Okay, let's break that down for the listener, because the Maillard reaction is basically the secret engine behind everything that tastes good in the culinary world.
It truly is. The Maillard reaction is a complex cascade of chemical reactions that occur between amino acids, the building blocks of proteins, and reducing sugars when they are subjected to heat.
Like when you sear steak or bake bread.
Exactly. Or roast a traditional coffee bean. The heat forces the amino acids and sugars within the seed to react, creating hundreds of new, highly aromatic flavor compounds.
Melanoidins, right, that give it the brown color.
Yes, melanoidins and various pyrazines and furans that give us those roasted, earthy caramel notes. So the Sasak people apply this exact same thermal manipulation to local soybeans.
They roast them.
They roast them aggressively. They push the Maillard reaction to its absolute limit without completely incinerating the legume.
So they are essentially forcefully altering the chemical structure of the soy to mimic the dark, bitter profile of a dark roast toffee.
Correct. And once it's ground and brewed, the resulting hot liquid visually and aromatically occupies the exact same space in a social setting as traditional coffee.
But it serves a different functional purpose.
Yes. Kopi Kedele acts as an alternative for community members who can't tolerate high caffeine, maybe due to age, gastric issues, or cardiovascular sensitivity.
But ethnobotanical traditions rarely settle for just a placebo. The sources explicitly document the medicinal claims associated with this practice. Because the base material is soy, the text says local wisdom dictates it is highly effective at lowering cholesterol.
Which is a bold claim.
Right. Is there a physiological basis for that claim, or is it purely a cultural belief? I mean, can a roasted soybean tea actually impact cardiovascular health?
There is actually a very strong biochemical foundation for it. Soybeans are incredibly rich in phytosterols.
Phytosterols.
Yes, they are plant-based compounds that are structurally very similar to human cholesterol. When you consume phytosterols, they actually compete with the actual cholesterol in your digestive tract for absorption into the bloodstream.
Wait, really? So they block the bad stuff?
Essentially, yes. The plant sterols block the absorption of the harmful cholesterol, causing it to be excreted. So the Sasak people have developed a daily social ritual that masquerades as a morning cup of coffee, but functions mechanically as a proactive cardiovascular intervention.
That level of preventative healthcare embedded seamlessly into a daily habit is just staggering.
Yeah.
You aren't taking a pill. You're participating in community life while actively managing your lipid profile.
It's beautiful design.
And the ingenuity in Lombok isn't limited to legumes. The research details an even more exotic alternative known as Kopi Gaharu, or eaglewood coffee. Now, eaglewood is something I associate entirely with the fragrance industry.
Oh, absolutely. Gaharu, or garwood, is sourced from the Aquilaria tree. It's one of the most legendary and expensive botanical materials on the planet.
Because of the resin, right.
Right. Its primary fame comes from this incredibly complex resinous wood that forms when the heartwood of the tree is infected by a specific type of mold. The tree produces this dense, wildly fragrant resin as a defense mechanism against the fungus.
And that resin-soaked wood is highly prized for incense and perfumes.
Very prized. But the Sekeni research observes a completely different use case by the Sasak tribe. They utilize the leaves or the seeds of the agarwood tree to brew a dark, tea-like coffee substitute.
And the functional claims attached to Kopi Gaharu in the text are vast. It states the local population uses it to treat deep, systemic fatigue, to cure the flu, and this is the claim that made me stop and reread the sentence. They believe it possesses significant anti-aging properties.
Meaning it keeps the consumer looking young and vital.
Right, but I have to push back here. In Western medicine, anti-aging usually means expensive peptides or retinol creams. How can a brewed cup of agarwood leaves reverse aging?
Well, it requires translating the cultural concept of aging. In many traditional medicine systems, aging is not merely viewed as the cosmetic wrinkling of the skin.
What is it then?
It is understood as a systemic degradation of vitality. It's driven by chronic inflammation, oxidative stress, and the physical toll of a harsh agricultural lifestyle.
Okay, that makes sense.
Now, let's look at the pharmacology of the Aquilaria tree. Both the resinous wood and the leaves contain highly complex sesquiterpenes and potent antioxidant compounds.
And when brewed?
When brewed and consumed, these compounds have been shown in pharmacological studies to possess strong anti-inflammatory properties. They also act upon the central nervous system as mild sedatives and stress relievers.
So it lowers systemic stress.
Precisely. Chronic stress elevates cortisol levels, that degrades cellular health, weakens the immune system, which explains its use against the flu, by the way, and it accelerates the physical markers of aging.
Wow. So by regularly consuming an antioxidant-rich brew, that neurologically dampens stress and physically reduces internal inflammation.
The Sasak people are addressing the root physiological causes of premature aging. It's not a magic potion that erases wrinkles overnight. It is a profound mechanism for preserving cellular vitality over decades of hard labor.
It is longevity medicine served in a teacup. The intentionality behind these brews is so deliberate. And the Security paper expands this concept of intentional hydration beyond hot morning drinks.
Yes, moving into fermented beverages.
Right. They detail traditional fermented drinks, which form a massive part of the ethnobotanical landscape. The text specifically highlights a drink called brem, derived from the fermentation of sticky rice.
Fermentation is perhaps the oldest and most universally applied ethnobotanical technology in human history.
But we usually just think of it as making alcohol for fun.
Right, for recreational intoxication.
Yeah.
But the research explicitly notes that brem is consumed with a very targeted functional purpose. According to local wisdom, it's utilized to warm the body and to significantly improve blood circulation.
What is actually happening during the fermentation of sticky rice that turns it into a circulatory aid?
The process is biologically transformative. When sticky rice is inoculated with local yeast cultures and specific enzymatic fungi, often traditionally cultured on rice cakes called rejj, those microorganisms begin to digest the complex carbohydrates.
Breaking down the starches.
Exactly. They break them down into simple sugars, organic acids, and varying levels of ethanol. When a farmer consumes brem, the presence of the alcohol acts as a vasodilator.
Meaning it causes the blood vessels to widen?
Yes, particularly the capillaries near the skin.
Which creates an immediate physical sensation of warmth.
Precisely. And consider the occupational reality of an agrarian community in Lombok. Farmers were often working in extremely damp, cool conditions, standing in flooded rice paddies during the early morning hours.
Their core temperature drops.
And circulation to their extremities is compromised. Consuming brem is an ergonomic intervention. The vasodilation improves blood flow, combating the physiological stress of the damp cold.
Ensuring they can maintain their physical labor. The fermentation unlocks properties in the grain that raw or cooked rice simply cannot provide.
It's fascinating how context defines the medicine.
It really is. But the researchers draw a very sharp line of contrast right next to brem with another functional drink called tuak. This beverage is derived from the sap of the sugar palm.
And the crucial detail here is that it's unfermented.
Exactly. The ethnobotanists emphasize that this specific version is purposefully left unfermented.
That distinction is paramount to its function. Standard tuak is a widespread palm wine. The naturally occurring yeasts in the air quickly ferment the sugary sap into an alcoholic beverage.
But tuak manis meaning sweet, right?
Yes, it is carefully collected and processed rapidly, often utilizing strict hygienic practices or immediate chilling and boiling to prevent the yeast from metabolizing the sugars.
Because allowing it to ferment would destroy the specific medicinal properties they are trying to harness. The text notes that the Sasak people trust this unfermented sweet sap to address major internal issues, curing diabetes, treating kidney stones, and maintaining general systemic health.
Which sounds paradoxical at first.
Totally. How does unfermented palm sap dissolve a kidney stone?
It comes down to the mineral density and the diuretic nature of the raw sap. The vascular fluid of the sugar palm is incredibly rich in specific electrolytes, particularly high levels of potassium, alongside various complex sugars and vitamins.
Okay, so it's packed with minerals.
Right. And in traditional medicinal frameworks, high potassium fluids act as powerful natural diuretics. They increase urine production and alter the pH balance of the urinary tract.
Oh, I see.
By increasing the flow rate and modifying the chemical environment of the kidneys, regular consumption of the raw sap helps to prevent the crystallization of minerals like calcium oxalate that form kidney stones.
And it can assist in flushing out smaller existing stones. That is amazing. But what about the diabetes claim? Drinking a sweet, sugary sap seems totally counterintuitive for managing blood sugar.
It does. However, the glycemic index of pure, unrefined sugar palm sap is actually significantly lower than that of refined white cane sugar.
Really?
Yes. Furthermore, the sap contains various trace minerals and specific fibrous compounds that physically slow the absorption of glucose into the bloodstream.
So you don't get that massive spike.
Exactly. It's highly likely that the traditional use involves utilizing tuak manus as a safer functional sweetener alternative that prevents the aggressive insulin spikes associated with modern processed sugars.
Helping to manage or prevent the onset of metabolic syndrome within the community. The level of biological engineering happening in these rural kitchens is just astounding.
It's an incredibly sophisticated pharmacopoeia.
It really is. Whether it's driving the Maillard reaction in soy, extracting antioxidants from agar wood, utilizing yeast to create vasodilators, or halting yeast to preserve diuretic minerals, it makes you evaluate the liquids you consume daily.
It really highlights how passive our modern drinking habits are.
Totally. When you, the listener, pour a glass of water or a diet soda or a standard cup of coffee, the interaction is largely passive. We drink for basic hydration or sensory pleasure. What the Sasak tribe demonstrates is a proactive, deeply intentional relationship with liquids. Every brew is customized to interface with a specific physiological system.
It's a complete integration of diet and medicine. But to fully grasp how these communities can maintain such a vast array of functional plants, the coffee, the soy, the agarwood, the palms, we have to look beneath the surface. Ethnobotany doesn't begin in the teacup. It begins in the soil structure.
Which brings us to the third and final pillar of our deep dive, relying on the 2024 study by Prabhati et al. This research takes us back to East Java, specifically the Kalabaru district in the Banyuwangi Regency.
And here, the focus shifts entirely from the processing of the plants to the architectural design of the farms themselves.
The system utilized in Banyuwangi is known as agroforestry.
Agroforestry is perhaps the most crucial concept for the modern agricultural world to comprehend if we are to survive the current climate crisis. It is the direct antithesis of the monoculture farming that dominates Western food production.
To make the distinction really clear for the listener, think about the vast industrial farms you might see driving across the American Midwest. Thousands of acres of flat land, completely stripped of all biodiversity, planted with a single crop, just endless rows of corn or soy.
Right, it's basically a flat parking lot of one species.
That is monoculture, and it is incredibly vulnerable. If a specific pest arrives or if the region experiences an unexpected drought, the entire system collapses because there is no biological diversity to buffer the shock.
There's no resilience built in.
Exactly. But agroforestry, as practiced in Banyuwangi, rejects that flat two-dimensional vulnerability. It is three-dimensional farming. It is the construction of an interconnected, multi-story apartment building of ecology, where different species live on different floors.
I love that apartment building analogy. The verticality of the system is what makes it so resilient. The Prabhati paper breaks down this structure beautifully, starting from the highest vertical point, the canopy.
The penthouse floor.
The penthouse floor, exactly.
Yeah.
In Kalabaru, coffee plants are never grown in open, sun-baked fields. They are cultivated as an understory crop, intentionally planted beneath the sweeping canopy of larger shade trees.
The researchers specifically identify bananas and papayas as the dominant canopy layer in this region.
Yes, and while a banana leaf obviously provides shade, the text emphasizes a highly functional, dual-purpose relationship here.
How exactly does shading the coffee plant alter the physical outcome of the coffee bean? Because I know shade-grown coffee is a big buzzword now, but what does it actually do?
Well, coffee, particularly coffee Arabica, is highly sensitive to intense solar radiation and high temperatures. In a monoculture field, direct equatorial sunlight causes severe thermal stress to the plant.
It cooks it.
Pretty much. It accelerates the maturation of the coffee cherry artificially. The fruit ripens too fast, meaning the complex sugars and organic acids don't have time to fully develop inside the seed.
So you get bad bean.
You get a flat, highly acidic, and structurally weak bean. Furthermore, the intense sun bakes the soil, evaporating the moisture and destroying the fragile topsoil microbiome.
So the broad leaves of the banana and papaya trees act as a biological heat shield.
Exactly. They intercept the harsh solar radiation, lowering the ambient temperature directly surrounding the coffee shrubs. They also engage in high rates of evapotranspiration, essentially sweating moisture into the air,
creating a humid microclimate.
Right. This controlled, shaded environment forces the coffee cherry to mature slowly. The slow maturation allows for maximum nutrient density and sugar development within the bean, resulting in a vastly superior agricultural product.
But the canopy isn't just serving the coffee, it is directly serving the human farmers. The coffee harvest is an annual event. It takes an entire year of labor before you see a single dollar from that crop.
It's a long wait.
But the banana and papaya trees yield fruit continuously throughout the year. So while the canopy protects the cash crop, it also provides an immediate, constant source of food and secondary income for the farmers. It is ecological insurance.
And that concept of ecological insurance continues as we move down the vertical structure. We have the bananas and papayas creating the canopy roof, the coffee bushes forming the mid-level structure, and then the farmers utilize the ground level, the soil beneath the shade, to cultivate what the researchers call undercover vegetation.
The ground floor. The Peabody paper details a specific classification of root crops planted in this bottom layer. They list cassava, taro, arrowroot, and sweet potatoes.
Yes, the foundational crops.
In the local Banyuwangi dialect, these subterranean crops are collectively known as polo pendem, which beautifully translates to agricultural produce that grows buried in the earth.
The inclusion of polo pendem is a masterpiece of spatial and nutritional efficiency. Root crops like cassava and taro are uniquely adapted to thrive in low-light conditions.
Because they're shaded by the coffee and the bananas.
Right. They don't need the blazing sun because they focus their metabolic energy downward, swelling their root structures with dense carbohydrates. Furthermore, their root systems actively aerate the soil.
Like natural tillers.
Yes, preventing compaction and allowing water to penetrate deeper into the earth, which indirectly benefits the deeper taproots of the coffee trees above them.
It is a totally symbiotic vertical column. The canopy shades the coffee, and the roots aerate the soil for the coffee. But the macro effect of this microecosystem is what truly matters for the community.
This raises an important question. How do these root crops impact the community at large?
The text makes a profound point about how the heavy reliance on these polo pendem root crops impacts the sociological stability of the region. It is the ultimate strategy for local food security.
This cannot be overstated. Throughout Southeast Asia, the primary caloric staple is rice. And while rice is deeply culturally ingrained, it is also highly susceptible to climatic disruption.
A failed monsoon season, an unseasonal flood.
Or a pest infestation. Any of those can wipe out a rice harvest entirely, plunging a rural community into immediate famine.
Which is the inherent danger of relying on a single caloric pillar.
Precisely. But the agroforestry system in Calabaru has engineered a caloric safety net. The farmers have drastically diversified their portfolio of staple carbohydrates. Cassava and taro are incredibly robust.
And drought-resistant.
Highly drought-resistant.
Sure.
And because the edible biomass is buried safely underground, they are largely protected from severe weather events and surface pests.
So if the rice crop fails entirely, the village does not starve.
Exactly. They have an immense reservoir of dense, starchy calories waiting patiently beneath the soil of their coffee farms. It represents total food sovereignty.
And the ethnobotanical record shows us exactly how those subterranean calories are utilized. Because you can't just pull raw cassava out of the ground and eat it.
No, absolutely not. Many varieties actually contain cyanogenic glycosides, which are toxic if not processed correctly.
Which is wild. The journey of the polo pendem continues right into the kitchen, showcasing deep culinary integration and chemical transformation. The source highlights specific traditional foods that serve as direct rice substitutes.
The processing techniques are highly evolved. They must neutralize any toxicity and transform the complex starches into digestible, long-lasting formats.
The paper specifically details the creation of gethuk and taiwo. Gethuk is made by thoroughly boiling the cassava to gelatinize the starches and eliminate toxins, then mashing it, often with coconut and palm sugar, to create a dense, sweet, highly caloric staple.
It's incredible energy food.
And taiwo is even more focused on longevity. It involves sun-drying the cassava to remove all moisture, turning it into a stable flour that can be stored for months or even years.
Which is perfect for food security.
Right. When needed, it is steamed to mimic the fluffy texture and caloric density of rice. They also slice and fry the various tubers into durable chips that can be stored indefinitely.
They are taking the raw, defensive starches grown in the shadows of the coffee plants and chemically manipulating them into the foundational energy source that sustains the physical labor of the village. It is survival chemistry.
But the Peabody text concludes with a detail that elevates these root crops from mere survival rations to sacred artifacts. It reveals that these specific foods, the gethuk, the tiwol, the processed polo pendem, are deeply integrated into the local traditional village rituals.
It brings it all full circle.
They aren't just eaten casually. They are formally presented as offerings during ceremonies and shared meticulously during communal celebrations.
Which brings the entire massive ethnobotanical cycle to a perfect close. It proves that within this indigenous framework, nothing is merely utilitarian. The food that saves you from starvation during a drought becomes the food you offer to the divine during a celebration.
The soil grows the root sustains the body, and the transformed root binds the community together spiritually.
It is a completely unbroken loop of reverence and survival.
So what does this all mean? When we synthesize the breadth of what we've discussed today across these 3 research papers, the sheer scale of the ingenuity is humbling. We began in the hamlet of Indrokilo in central Java, where a profound zero-waste philosophy turns coffee leaves into anti-inflammatory stamina medicine.
It utilizes the rotting fruit skin to brew sweet Cascara tea.
It processes stems into fuel and bark into soil-regenerating compost, and extracts the defensive sap to weaponize it as a natural pesticide, all while elevating the fragrant flowers into the sensory heart of the Bangkokan harvest ritual.
Then we moved east to Lombok, where the Sasak tribe forced us to reconsider the very definition of a beverage.
They showed us how to manipulate the Maillard reaction in soybeans to create Kopi Kedele, a social drink that actively lowers cholesterol. They brew antioxidant-rich agarwood leaves to combat systemic stress and cellular aging.
They utilize complex yeast fermentation to create brem to warm the blood of damp farmers. And they halt fermentation in sugar palm sap to create tuak, a potassium-rich diuretic to manage kidney health.
Finally, we explored the 3-dimensional architecture of survival in Banyuwangi. We saw how the agroforestry canopy of bananas and papayas creates a microclimate to protect the cash crop while providing immediate fruit,
while the subterranean level yields polopindum root crops.
Those roots transform through culinary chemistry into gethuk and tiwul, provide total food security against a fragile climate, and anchor the spiritual rituals of the community.
The overarching lesson embedded in the ethnobotany of Nusantara is a masterclass in genuine sustainability.
Truly.
The modern world treats agriculture as an extraction industry. We take the bean, we take the profit, and we discard the ruin. But the local wisdom detailed in these sources proves a timeless foundational rule. The botanical world will provide absolutely everything a human community requires.
Food, medicine, shelter.
Everything. It will synthesize the alkaloids to heal you, grow the wood to warm you, provide the complex carbohydrates to sustain you, and offer the sensory beauty required for your spiritual rituals. But it will only do this if humans approach the plant not as a factory to be exploited, but as a deeply complex partner that requires understanding, care, and profound gratitude.
It demands a complete recalibration of how we walk through the physical world. And that brings us right back to your kitchen, to the mug you are holding right now. Tomorrow morning, when you pour that hot water over those ground-up seeds, I want you to look closely at that dark liquid.
Look past just the caffeine.
Yes. I want you to visualize the vast, complex biological architecture that you cannot see: the medicinal leaves, the woody stems, the defensive sap, the fragrant flowers, the protected canopy above, and the dense, life-saving roots below.
The whole tree of life.
Exactly. And as you take your next sip, I want to leave you with this provocative thought to carry through your day. If our modern industrialized society is only utilizing a fraction of a % of the coffee plant's true potential simply because we have forgotten the ancient indigenous wisdom of looking at the whole organism, what else are we missing? What other everyday items, plants, and materials in our hyper-convenient disposable lives are we completely underutilizing? What other hidden trees of life are standing quietly in plain sight just waiting for us to remember how to see them?